Namaste and welcome to the team. I know it's your first day as a junior engineer here, and stepping into a modern DevOps environment can honestly feel a bit like drinking from a fire hose. But don't worry, I'm going to be your senior mentor today. Consider this explainer your official architectural orientation. We're going to completely demystify exactly how and why we use containers to build and ship our software here. Our main goal is to make absolutely sure your fundamentals are rock solid before you deploy your very first application with us.
Here is a quick look at our flight path for today's orientation. We'll trace the evolution of app hosting, compare virtual machines and containers, look at cloud deployment models, walk through the actual container lifecycle, and finally, introduce you to an alternative called Buildah. Let's get started.
Okay, let's dive into this with Section 1, the evolution of app hosting, from bare metal to containers.
To truly appreciate what containers do for us, you kind of have to trace this timeline with me. In the beginning, we deployed applications directly on big physical servers. Whether it was a massive IBM mainframe or just a rack server, the core problem was exactly the same. You almost never use the full CPU and RAM capacity. It's like renting a giant mansion for just one person, a massive waste. To fix that resource waste, the industry introduced virtual machines. Using a hypervisor, we basically chopped up one physical server into multiple logically isolated VMs, with each one running its own separate, full operating system. Honestly, it was a huge leap forward. But containers, they're just the next natural advancement in this story, effectively sharing the host's resources to eliminate even more of that leftover waste.
Moving right along to Section 2, let's really break down virtual machines versus containers and understand their resource efficiency.
Now, you might be wondering, if virtual machines are so rock solid and secure, and they definitely are, why are we even bothering to move to containers? Well, think about our AWS EC2 instances, which are essentially just virtual machines in the cloud. Even with those VMs, we realized we were still wasting space. I mean, how many times have you actually seen an EC2 instance run completely out of memory? It's super rare. Most of the time, you're still sitting on wasted memory and CPU capacity. If a business runs a million instances, wasting half their resources across the board is a massive, massive financial loss. We moved to containers because they literally squeeze every last drop of efficiency out of our hardware.
The sheer difference in scale here is what makes this a total game changer. When you take a backup of a virtual machine, you're creating a snapshot. Those snapshots are incredibly heavy. We're talking gigabytes in size, mainly because they have to include an entire bloated operating system. Containers, on the other hand, are megabytes light. A typical container image might only be 100 megabytes. To put that into perspective, because they are measured in mere megabytes instead of massive gigabytes, they are insanely lightweight, highly portable, and super easy to zip across our network.
So what's actually inside this thing to make it so unbelievably small? A container is basically a neat little package that bundles up your application code, your specific app libraries, and a minimal base image for system dependencies, literally just enough to run Python or Node.js, for example. The secret sauce here is that it absolutely does not contain a full operating system. It just borrows the host operating system for all the heavy lifting. Because we rely so heavily on these base images, a really crucial best practice you're going to learn on the job is to always keep these base images minimal. Constantly scan them for vulnerabilities and keep them updated.
Now, as an engineer, you got to understand the trade-offs. We are sacrificing absolute isolation to get that incredible speed and tiny size. Because virtual machines have completely independent operating systems, they provide, absolute security. Containers, on the other hand, well, because they share that underlying host OS and kernel, you only get logical isolation, right? It's not absolute. And since sharing that host kernel obviously impacts overall container security compared to a hypervisor, our best practice here is to strictly control container permissions and continuously update our images to patch any vulnerabilities. We essentially trade a tiny bit of that ironclad VM security for brilliant, unmatched resource efficiency.
All right, Section 3, Cloud VM Deployment Models. Where are we actually running all these containers?
You might naturally think we just install our containers straight onto bare metal physical servers, but we actually use a sort of hybrid deployment stack. Step 1, a cloud provider manages the physical server somewhere in a data center. Step 2, we spin up a virtual machine, like an EC2 instance, right on top of it. Step 3, we install our containerization platform, something like Docker, onto that specific VM. And then finally, Step 4, we deploy our individual containers. So actually, scratch the bare metal idea. We are literally stacking containers directly on top of cloud virtual machines.
So why exactly do businesses prefer running container platforms on cloud virtual machines instead of doing it all themselves? One phrase: maintenance overhead. If we had to manage our own physical servers, we'd literally need an entire dedicated team just to install security patches, replace broken hard drives, and deal with cooling. By deploying our container platforms onto cloud VMs, we totally offload all that physical hardware maintenance to the cloud provider. It's a lifesaver. It lets our DevOps team focus entirely on what matters, managing the applications.
Moving to Section 4, let's talk about the practical stuff, the container lifecycle, from code to deployment.
Map this out in your head with me. Let's say you're building a simple, real-world web application. Step 1, you write a basic text file called a Docker file, and this is where you define your app and all its dependencies. Step 2, you use the command docker build to submit that text file to the Docker engine. Step 3, the engine churns through all your instructions and spits out a static, lightweight Docker image. Finally, Step 4, you use the command docker run to execute that image. The exact moment that image starts running, boom, it becomes a live container, serving your web application to the world. And that right there is your daily journey from code to deployment.
Finally, Section 5, meet Buildah. This is the alternative way of building without a daemon.
Okay, so to truly understand why Buildah exists, you first have to understand a major architectural flaw in Docker. It's called a single point of failure, or SPOF. Docker relies incredibly heavily on the Docker engine, which is this background daemon constantly running. If that central engine crashes for whatever reason, all of your containers just stop working. Imagine your customers trying to use your web app and the whole thing is completely down just because one background engine crashed. That is an absolutely terrible scenario for us.
And this is exactly how Buildah steps in to fix the problem. Docker requires that centralized engine daemon, which makes it a glaring single point of failure, and honestly, it creates a lot of heavy layers on your disk. Buildah, on the other hand, is completely daemonless. You basically just write simple shell scripts to build your images instead of relying on a central engine, which gives us much higher resilience. Plus, it outputs fully OCI-compliant images, completely solving that heavy storage layer problem while still remaining perfectly compatible with everything else. To put it as simply as possible, Buildah aims to solve the layers problem and completely eliminate that single point of failure. And because it integrates so seamlessly with modern container tools like Skopeo and Podman, you are going to see more and more complex projects in our organization utilizing Buildah to securely build our images. It's definitely the future around here.
So, as we wrap up your architectural orientation, I want to leave you with this one provocative question to ponder. As you sit down at your desk to write the code and deploy your very first application with us, will you default to an older architecture that relies on a single point of failure, or are you ready to jump in and learn how to build without a daemon? Your choice dictates the overall resilience of your software. Thank you so much for joining this explainer. I really hope it gave you absolute clarity on containers. Oh, and don't forget to subscribe to ZinDigital DevShub for more deep dive technical explainers just like this one. Welcome to the team.